Hi, so here what we have is the formula we saw in the previous video. And I'm recalling this because I want to highlight the relevance of the interest rate. As you can see, the interest rate is the major thing that determines the difference between the present value and future value. So it is important that you master this interest rate and you know how to handle with different interest rates. Because when you go to the bank or in whatever investment, you will have different interest rates for different periods, and that take into account differently the compounding effect. Okay? Imagine that you go to the bank and the bank offers you 5% per semester. So you have a certain amount you deposit in the bank, and the bank will tell you that it will pay you 5% on each semester. Your next question may be, how much will you have after 1 year? The obvious answer is that if you receive 5% in each semester, since you have 2 semesters in a year, in the whole year you will get an interest rate of 10%. So you multiply 5% by 2. And what you are calculating is the stated annual interest rate. So the stated annual interest rate is simply the rate for a certain period, m, times the number of periods within a year. So if we are talking about this example, this would be 5% semesterly rate times 2. If you have the monthly rate, you would multiply it by 12, and you would get the annual rate based on a monthly rate. And you could do this for any period smaller than a year. And this way, you will get the stated annual interest rate. Okay? Now let's do the other way around. Imagine that you go to the bank and the bank tells you that there is a stated annual interest rate of 10% and they will pay you quarterly. So every single quarter there will be an interest payment. If the bank tells you that it will pay 10% in a year and the interest payments are quarterly, the next obvious thing to do is dividing the 10% by 4. So we would get the proportional rate. This proportional rate is simply the stated annual rate divided by m, the number of periods. And this way you would get the rate for that period you are trying to find. The quarterly rate would be the stated annual rate divided by 4. The monthly rate would be the stated annual rate divided by 12, and so on. Okay, so now we know how to transform a stated annual rate into a proportional rate, or to transform a proportional rate into a stated annual rate. But here we are looking at the relationship between different periods without taking into account the compounding effect. We are just looking at the simple interest. But actually, when you have an investment, most likely there will be a compounding effect. Let's see what happens and how the calculations change. If you have a deposit for 1 year with semesterly payments, you can split your year in 2 semesters. So we will make a certain deposit for 1 year and we get interest over this first semester, half a year, and for the second semester. So we will have interest in these 2 periods. We know already how we transform a certain initial capital into a certain future capital after 1 period. So if you want to know how much you will have after 1 semester, what you have to do is multiplying C0 times 1 plus the interest rate you get in 1 semester. So we know this already. We just need to know the initial capital and the interest rate to know how much you will have after 1 period. And here we are using the semesterly rate. Let's say that this is 5% and you have 1,000 euros. So you transform 1,000 euros, and if you multiply it by 1 plus 5%, you will get 1,050. What we are doing is using this C0 and an interest rate of 5%. We get 1,050 after one semester, after 1 interest payment period. But then we have to see what happens at the end of the year, because we have another semester. So there will be another interest payment. And this here will be C0 times 1 plus the semesterly rate to the power of 2. We are compounding interest, so we multiply again by 1 plus r. And if you do this, you will get the capital after 1 year, which will be 1,102.5, okay? Which is this capital plus 5%. As you can see, the interest payment you got in the first period was 50. You got 1,000, then you add 5%, so you got an interest payment of 50. In the second semester, the interest payment is 52.5. And as you can see, the interest payment is larger in the second period. This is the so-called compounding effect, because you will have interest on top of interest. The second semester, even though the time frame is the same, it is 1 semester, as in this case, you will have different interest payment because you will have interest over the interest of the first period. So there will be a compounding effect. So at the end, you won't get the 10% interest rate. You will get a little bit more because the compounding effect between the two periods. So let's calculate the effective annual interest rate. The effective annual interest rate, EAR, will be equal to 1 plus the rate for the smaller period, for the semester, for example, to the power of m, the number of periods, the number of semesters, and then we subtract 1. So it's not simply multiplying the semesterly rate by 2. We have to compound the semesterly rate twice, so we are taking into account the compounding effect, then we subtract 1 and we get the effective annual rate. And if you do this with those numbers you have, you will get the effective annual rate if you have 5% paid on each semester. This will be 1 plus 5% squared minus 1, and this will be 10.25%, which is the implied interest rate you got here in a year. Okay? So here you have the effective annual rate. Let's now invert the calculation again. If you have an effective annual rate and you want to find the monthly rate, you don't simply divide by the number of periods. Again, you have to take into account the compounding effect. And we do this by inverting this calculation. So if you want to find the equivalent rate, so if you want to find the monthly rate, for example, you have 1 plus effective annual rate to the power of 1 divided by m minus 1, which is not simply dividing by 12. If you want to find the equivalent rate for a month, if you have an annual rate of 12%, you don't divide by 12. The monthly rate is not 1%. It is a little bit less. It's 0.8333%. Okay? So we have here 4 different calculations. The effective annual rate and the equivalent rate, and then the stated annual rate and the proportional rate. 2 annual rates and 2 rates for smaller periods, for a month, for example. We can use any of these. What will determine what calculation we have is the type of rates we have as original information. If you go to the bank may either offer you this or this, so they can tell you that you have an annual rate, and then it can be either effective or stated. And then if you want to find the monthly rate based on that annual rate, the calculation you choose depends on whether you have a stated annual rate from the original information or an effective annual rate. All these calculations may be used, it depends on the context, it depends on the information you have.